Now in the previous lecture, we have learned what's a binary heap and we have learned why we need a binary heap. Now in this video, we will talk about common operations that we can perform on a binary heap. So these are the common operations we can perform on a binary heap. First one is creation of binary heap. The second one is pick the top of binary heap, then extract minimum, extract maximum, then the traversal of binary heap and the size of binary heap and inserting a value to the binary heap, and finally deleting entire binary heap. Now before digging into these operations over here, we need to know the implementation options for binary heap. So here we have two options. We can implement binary heap using array implementation, and we can use reference or pointer to implement binary heap over here. So there is a small difference between these implementations. But here we will use array implementation because, as I mentioned before, array implementation is the best fit for binary heap. So let's get started with array implementation. Now here we will see how the binary heap is stored in the memory when implementing it using array. Now we know from the binary tree section that left and right children of the binary tree are stored in array using these formulas over here. So here also this is applicable for binary heap. As we said before, binary heap is a binary tree, so that's why the array implementation is same as with the binary tree in this case. So here, as you remember, we are skipping the zeroth index always because this makes our mathematical calculations easy. So in the first index, we are always storing the root node. Now after the storing the root node, based on these calculations over here, we are storing left and right child. So here you can easily see that by multiplying 1 by 2, we are getting 2, and we are storing the left child of 5 to this second index over here. And the right child of 5 is located at the index of 3 because here we are multiplying 2 with 1 and plus 1 is going to be 3. So that's why we have stored it 3. So this continues like this until we have stored all elements in this binary heap over here. So this is how elements are stored in the array in case of binary heap when we are implementing it using array. So based on these formulas over here, a binary heap is located in the memory like this. Now let's continue to the common operations. Now the first operation is creation of binary heap. So here, when we create a binary heap, we are initializing the array based on the size that we are getting from the user, and we are setting the size of binary heap to 0. Because in this case, in our binary heap, we don't have any elements, so that's why the size of binary heap is 0. And here we need to take into account that whenever we are receiving a number from a user for fixed size of array, in this case we are putting +1 because we are always skipping the first index, so that's why we are going to add +1 in this case to our size over here. Now based on this logic, let's head over to Java and create binary heap class over there for creation of binary heap using array implementation. Now here, the first thing that I'm going to do, I'm going to create a new file which will be the binary heap file. So I'm going to name it binary heap.java, and inside this file we are going to create our binary heap class. So I'm going to declare our class like this: public class binary heap. Then the first thing that we are going to do inside this class, that we are going to declare our array. So in this case our binary heap will be the type of integer, so that's why I'm creating integer type of array. Then after declaring the array, I'm going to declare one more variable over here which will keep the size of binary tree over here. So in this case it's going to be like this: size of tree. So it's obvious that it's going to be the type of integer because in this case we are going to keep the size of tree over here. Now then inside constructor we are going to initialize our array over here. So it's going to be like this: binary heap. So as a parameter it will take the size because we are getting the size of the array from the user. Then we are going to initialize our array like this. So it's going to be like this: arr new int. So as we said before, it's going to be size +1 because here we are skipping the 0th index, so that's why whenever we are creating array over here, we are creating size +1. Then the next thing that I'm going to do, I'm going to set the size of tree 0. So in this case, size of tree will be set to 0. Then at the end, I'm going to print out to the console saying that a binary heap has been created. So it's going to be like this: system out print binary heap has been created. Now with this, we have successfully implemented creation of binary heap using array over here. Now let's see how this is working in practice. So let's run this one in the main class to see that if this is working properly or not. Now here inside main class, I'm going to create an instance of binary heap class. So it's going to be like this: binary heap new binary heap is equal to new binary heap For example, let's create the size of 5. Now, after doing so, if I run our code, you will see that it's going to print out to the console saying that the binary heap has been created over here. Now you see that the output printed out over here saying that binary heap has been created over here. Now with this, we have created a binary heap using array implementation in Java. Now let's see what's the time and space complexity for creation of binary heap. Now in this case, it's obvious that it's going to take a one-time complexity because inside this constructor over here, we are just initializing the array and we are setting the size of 3 to 0 and we are printing out to the console this message over here. Now these 3 lines of code, all of them one by one will take a one-time complexity, so that's why the time complexity for creation of binary heap using array implementation takes a one-time complexity. Now the space complexity in this case is O(n) because whenever we are creating binary heap using array implementation, we are allocating n number of contiguous cells in the memory, so that's why it will take O(n) space complexity. So with this, we have successfully implemented binary heap using array implementation. Now let's continue to the next operation, which is pick of heap. Now when we say pick of heap, we simply mean the root of heap. So in this case, we are just returning the root of heap from this heap over here. Now in our case, the root of heap is 5. So this means that whenever we are calling pick of binary heap, in this case, we are going to return 5 over here. Now in case of array implementation, it can be easily seen that in this case, root node is located at the index of 1. So this means that whenever we are calling a pick method for binary heap, in this case, we are going to return the value that is located at the index of 1. Now here, an important moment is that here, whenever we are calling a pick method for binary heap method, we are not removing this root node from the binary heap. We are just returning the value of this root node over here. So this means that it doesn't matter how many times we are calling a pick method for binary heap, every time it's going to return the value that is located at the index of 1 in this array over here. Now based on this logic, let's head over to Java and create our pick method inside binary heap class that we created before. Now in this case, before creating pick method inside this binary heap class over here, first I'm going to create isEmpty method because we are going to use isEmpty method inside pick method. So that's why first I'm going to check that if this binary heap is empty, in this case, it means that we don't have any value in our root. So this means that we cannot return anything. We are just going to return null, saying that the binary heap is empty. Otherwise, we are going to return the value that is located in the array at the index of 1. So that's why first I'm going to create isEmpty method over here. Now it's going to be like this, public boolean. So isEmpty method will return boolean. If it is empty, it's going to return true. Otherwise, it's going to return false. So I'm going to name it isEmpty. So it's not going to take any parameter. So based on condition, it's going to return false or true. So how can we identify that if our binary heap is empty or not? So in this case, we can identify it based on the size of 3. So if the size of 3 is 0, it means that our binary heap is empty. Otherwise, it's not empty. So here I'm going to write condition like this. If size of 3 is equal to 0, it means that this binary heap is empty. So that's why I'm going to return true. Otherwise, I'm going to return false. Now, based on size of 3, we can identify that if this is empty or not. So if it is returning false, it means that it's not empty. Now, by using this method, we are going to implement pick method over here. So the pick method will be like this. So public int. So in our case, it's going to return the type of integer because in this case, our binary heap is integer. Now, here we are going to check that if is empty, it means that we don't have any element in our binary heap. So in this case, I'm just going to print out to the console saying that the binary heap is empty. Binary heap is empty. So in this case, we are just going to return null. Otherwise, we are going to return the value that is located at the index of 1. So it's going to be like this, return ARR with the index of 1. Now with this, we have successfully implemented our pick method. Now in this case, when we have created our binary heap over here, we know that our binary heap is empty. So this means that if I call this method, pick method for this binary heap over here, it should return saying that the binary heap is empty. So let's run this method for this binary heap that we created over here to see the output. Now here, when we run our code, you see that we have an error over here. So inside this class, instead of return int, we need to put integer because in Java it causes an error. So if I put integer, in this case, you will not have any problem over here. So if I run it, you'll see that in this case it's just going to return null and saying that the binary heap is empty in this case, because in this case we have not inserted any element to our binary heap over here. Now as you can see, the output says that the binary heap is empty. So this means that we don't have any element in our binary heap to return for pick method. So with this, we have successfully implemented pick method. Now let's see what's the time and space complexity for pick method that we have implemented over here. Now, before continuing to the heap method, let's first identify the time complexity for isEmpty method. Now in this case, the time complexity for isEmpty method is O1, because in this case, based on the size of tree, we are returning true or false. So here we are not performing any time consuming operation. So the time complexity for isEmpty method is O1. Now, if we continue to the pick method, so in case of pick method, we are using isEmpty method. So as we mentioned, isEmpty method takes O1 time complexity. Then in the next line of code, we are printing out message to the console. So this line of code will take O1 time complexity. Then at the end, we are returning null. So this one also will take O1 time complexity. Now then, if it is not empty, we are returning the value of first cell from this array over here. So we know from array section that accessing an element of array using their index takes O1 time complexity. So this return statement over here will take O1 time complexity. So if we combine these complexities together, we get O1 time complexity. So the pick method in case of array implementation in heap takes O1 time complexity. Now the space complexity is also O1, because in this case we are not performing any space consuming operation. So that's why space complexity is also O1. Now with this we have completed pick method. Now the next operation will be the size of heap. Now when we say the size of heap, we basically mean how many elements in the heap. So in this case, from this heap we can easily see that we have 7 elements in our heap. So we are going to return the number of 7 when we are calling size method for binary heap over here. So an important moment over here is we are not returning the size of array over here. So as you can see, in this case the size of array is 9, but the elements that we have in this array over here is 7. So we are going to return the number of the field cells from this array over here. So when we are creating binary heap class, we have created a variable for the size of heap. So in this case, based on that variable, we are going to create our function over here. So whenever we are extracting or inserting elements to this binary heap, we are going to increase or decrease the size of binary heap. So based on that variable, we can identify the size of binary heap. Now let's head over to Java one more time to create size of binary heap method for this binary heap that we implemented using array. Now here inside this binary heap class, we are going to create size of tree method. So in this case, it's going to be like this: public int. So I'm going to put size of binary heap. Then it's not going to take any parameter. So here, all we are going to do, we are just going to return tree size that we created over here. So I'm just going to return size of tree from here. So we can print out message to the console saying that the size of tree is like this. So it's up to you. In this case, I'm not going to print out anything to the console. We are just returning the size of tree in this case. So whenever we are running this method size of binary heap method, it's going to return this variable over here. Now it's obvious that the time complexity for this method over here will be O1 and the space complexity is O1, because here we are just returning the value that we have in this variable over here. So the time and space complexity for this operation is O1. Now let's continue to the next operation, which is traversal of binary heap. Now as I mentioned before, binary heap is a binary tree, so we learned that in case of binary tree, we can do 4 types of traversals. So we can do pre-order traversal, in-order traversal, post-order traversal, and level order traversal. Now in this case, I'm not going to go to the details of pre-order traversal, in-order traversal, and post-order traversal, but for explaining a traversal in case of binary heap, I'm just going to use level order traversal. Now in case of level order traversal, we know that we are visiting elements level by level. And when we are implementing binary heap using array implementation, level order traversal becomes very easier, because in this case, we are just traversing through this array over here, because in this array, the elements are located level by level. So as you can see, in the first level, we have 5, and in the first index, we have 5. So in the second level, we have 10 and 20, then it continues 10 and 20, and all elements are located from left to right. Now, whenever we are calling level order traversal for this binary heap over here, it's going to be like this. First, we are going to visit first level, which is 5, then we are going to continue to the next level. In the next level, we have 10 and 20, then we are going to continue to the third level. So in the third level, we have 30, 40, 50, and 60. Now as you can see over here, whenever we are doing level order traversal, each time we are starting from left to right. So the order in this case will be 5, 10, 20, 30, 40, 50 and 60. So you can easily see that these elements are located in the order that we have mentioned over here. Now based on this logic over here, we are going to create level order traversal in practice. Now here inside binary heap class, after size of binary heap method, I'm going to implement level order traversal. So our method will be like this: public void level order. So this method will not take any parameter, so we are just going to visit the all elements of the binary heap and we are going to print out them to the console. Now as you remember, when we are creating an array over here for this binary heap, we have said that we are not going to use the zeroth index of array. So this means that whenever we are traversing through the binary heap, we are not going to start from the zeroth index. So we are going to start from the first index. So that's why our loop will be like this. For int I is equal to 1, and it will continue until we reach the size of the binary heap. We are not going to print out the values from the empty cells, so that's why we are going to use size of array property over here, and in each iteration we are going to increase I by 1. Now after doing so, we are going to print out to the console the values that are located in these cells over here. So it's going to be like this: system out print. So here I'll put array name, which is ARR, and then we are going to put the index of I. And here I'm just going to put empty space over here to make our output more readable. Now after doing so, here I'm just going to print out new line character to see our output properly. So in this case it's going to be like this: print ln new line, new line. Now with this, we have successfully implemented level order in this case. Now in this case, if we run level order traversal for this binary heap that we created over here, in this case it's not going to print out anything, because in this case we don't have any element in our binary heap over here. So if I run our code, you will see that nothing happens in this case. You see that it hasn't printed anything to the console because in this case we don't have any element in our binary heap. Now let's see what's the time and space complexity for this level order traversal. So it's obvious that the time complexity is O(n), because in this case we are visiting all elements of the binary heap over here. So this loop over here will take O(n) time complexity, and printing out to the console these values will take O(1) time complexity. Now if you combine all these complexities together, we get O(n) time complexity. Now the space complexity is O(1), because in this case an extra memory is not required to perform this operation over here. So that's why the space complexity is O(1). Now with this we have come to the end of this lecture. So in this lecture we have discussed simple operations that we can perform on binary heap. Now in the next lecture we are going to perform insert a node in a binary heap. So it's going to be the separate lecture, because in case of insertion we have to perform extra operations in case of binary heap. So we know that from binary tree that whenever we are inserting a node to the binary tree, we are going to insert it to the next vacant place, but in this case we have to heapify the binary heap to maintain the properties of binary heap, because otherwise if we insert it as binary tree, it's going to violate the properties of binary heap. So that's why after insertion we need to check that if this inserted node is maintained the properties of binary heap or not. So if it is not maintained, we have to do some extra operations to make it conform with the properties of binary heap. So let's continue to the next lecture to see how insertion works in case of binary heap. So see you in the next lecture.